my dear friends and students, from my first video. All of you can easily remember these points which I wrote on the board. The first one, that is the circular motion. So all of you know that the motion of object along the circumference of circle is called as circular motion. Now depending upon the speed of that object, whether the object moves with the constant speed or with the change in speed, we can classify the circular motion into two categories, that is the uniform circular motion and non-uniform circular motion. In uniform circular motion, any object perform the circular motion with the constant linear speed, angular speed and angular velocity. Only the linear velocity of that object changes because of changing direction of velocity. Because when the object moves from one position to other position, the direction of velocity changes continuously. Now in case of non-uniform circular motion, the object moves along the circumference of circle but with the change in speed. Now when we consider the vertical circular motion, then when the particle moves from one position to other position, that is from lowest position to highest position, its speed changes. So at the lowest position, its speed is under root of 5 rg or gr, and at the highest position, its speed is simply under root of rg. It means when that object performs the vertical circular motion, there is a change in speed also. That's why vertical circular motion is the example of non-uniform circular motion. Then we had seen the two characteristics of the circular motion. Circular motion is a accelerated motion. Any motion in which velocity of that object changes with respect to time, that motion is considered as an accelerated motion. And the motion which repeat its path after the definite interval of time, called as a periodic motion. So these are the two characteristics of the circular motion. Then we had seen the radius vector, that is the vector drawn from center of circle to the position of particle at that instant, called as a radius vector. That is, for position A, OA is a radius vector. For position B, OB is a radius vector. Similarly, for position C, it is OC. For position D, it is OD. Now you can keep in mind certain points related to the radius vector for the objective question. That is, the name indicates a radius vector. So that's why it is a physical quantity which has both magnitude and direction. That's why it is called as a vector quantity. Now what is the magnitude of a radius vector? So magnitude of radius vector is simply the radius of that circle or circular path followed by that object. What is the direction? Keep in mind, direction of radius vector is always away from the center or toward the position of that object, as it is simply the distance between the two positions, that is between center and the point where the object is present at that instant. That's why its unit is meter or centimeter, and dimension is simply n to the power 1, m to the power 0, t to the power 0.
Yeah.
In this video, now we have to consider the three physical quantity related to circular motion. The first one we have to define as angular displacement. Now what is angular displacement? Simply when any object performs the circular motion, then we have to consider the two positions A and B. Let A be the initial position of that particle and B be the position of that particle after certain time. Now if we join these two positions with the center, that is, I draw here the first position A with the center as a OA, the second position, that is OB. Now here we get the two radius vector, that is OA for position A and OB for position B. Now here we get the angle between that two radius vector drawn for the two positions. So that's why I write here definition as angle made by a radius vector. Here angle made by radius vector, where at the center of circle, when that object move from one position to other position in a given time. So this is the simple definition you have to keep in mind as a angle described or traced or made by radius vector at the center of circle when the particle moves from one position to other position in a given time. Now if you want to derive the formula for angular displacement, then consider A be the initial position, B be the position of that particle after certain time. Then if we join that two positions, then we have OA equal to OB equal to the radius of circle. Then here we have the length of arc as a AB, which can be considered as a linear displacement of that particle, which is represented by delta S. And here whatever the angle we get made by radius vector, it is represented by delta theta. It means here we have to consider the three notation. The first one is a R, which represents the radius. Second one is a delta S, that is the linear displacement or length of arc, and delta theta is the angular displacement. So simply angular displacement is the length of arc upon radius. So angular displacement is denoted by delta theta, length of arc represented by delta S, and radius is represented by r. So by the formula we can represent the radius vector, angular displacement as a delta theta equal to delta S by r. Now here it is the angle, that's why its unit is measured in a radian. Now this is the physical quantity which doesn't relate to any fundamental physical quantity. That's why it has no dimension. So keep in mind, angular displacement is a dimensionless quantity. Now here we consider the direction of same physical quantity, that is the angular displacement. Now here the direction of angular displacement given by the two rules, that is the right hand rule and the right hand screw rule. Now here if we consider the right hand rule as, imagine the axis of rotation is to be held in your right hand in such a way that the thumb is in stretch direction and these fingers are curled around it. Now if these fingers gives us the sense or direction of rotation of that object, then this stretched thumb gives us the direction of that physical quantity. That is the rule I write here. Imagine the axis of rotation to be held in your right hand in such a way that here the fingers that are curled around the axis and the thumb is in stretch position. If the curl finger gives us the direction of motion, then the thumb gives us the direction of that physical quantity. Now here if we consider the second rule, that is the here right hand screw rule. Now if we kept here the screw, that is the right handed screw, in an inverted fashion in such a way that this is the head and this is the tip. Now if we rotate that screw in the direction of motion, that is in anti-clockwise direction, then here the tip gives us the direction of that angular displacement. Now if we move this screw in anti-clockwise direction, tip move in upward direction. If we rotate the same screw in clockwise direction, then the tip move in downward direction. So that's why right here, for the anti-clockwise motion, the direction of angular displacement is perpendicular and vertically upward, and for the clockwise motion, the direction is again perpendicular but vertically downward. Now the second physical quantity we have to consider as angular velocity. Now here it is the time rate of change of angular displacement, that is called as the angular velocity. Now if we consider delta theta as the angular displacement in time delta t, then we can define angular velocity by the formula as omega equal to limit delta t tends to 0 delta theta by delta t. Now here again we have to consider the direction of that angular velocity. Now the direction of angular velocity can also be found out by considering the same rule, that is the right hand thumb rule as well as the right hand screw rule. Now keep in mind the direction of angular velocity is same as that of the direction of angular displacement. It means for the anti-clockwise it is perpendicular and upward, and for clockwise motion it is perpendicular and that is vertically downward. Now if we consider the unit of that physical quantity, as it is the ratio of angular displacement and time. Angular displacement is measured in radian and time measured in second. That's why the simple unit, SI unit for the angular velocity as radian per second. Now here second is the quantity related to the time. That's why dimensions that can be written as 0 in length, 0 in mass and -1 in time.